All right, so the last thing we talked about the while loop and the do loop. And they're useful, but they're not as cool as the for loop. Okay? So with the for loop, it says if you know the exact number of iterations before it begins. Do you always know the exact number?
No.
Not always, but a lot of times you do. Now, a lot of times you do, or there's ways to figure out the number of iterations. Even if you don't really know, you can still use this anyway. Okay? So we can actually make a loop that counts down from 10 to 1. It says list off, find factorials, all that kind of stuff. So if we know what's going on, how many times it needs to go, this is a great loop. I pretty much use it for everything. Whether I know the number or not, you can still use it. So. All right, the syntax of it. Okay, the Java syntax is over here. It's for and some stuff in parentheses, which we'll talk about. Then it's got some braces, and then a statement. You can write it without the braces, okay? You can skip the braces, but then the loop only pertains to the next one line. I want to run their little thing here. I'm going to show you how you're going to screw up. It's not just you, it's everybody. So many people have issues with this. Okay, I'm going to copy this Java code out of here.
When do we know when to... I mean, is there a rule of thumb on when to use and when not to use the Hitchcock braces?
Okay. If you always use them, you're set. If you, that's what, if you think about it, it always works if you use them. But there's only certain times you don't have to use them. So if you're not sure, just put them in there. All right, let's put this code in here, make it pretty. All right, let's run this code and let's see what it does. Oh. All right, without looking in my error, what do you think the problem is? I don't know yet. I haven't found. It's got the right.
Don't you have to have an input?
Shouldn't need an input. I'm not inputting anything. I is declared there. I is declared. Huh. I don't see it.
Well, the program worked before you put that in there, so it's got to be inside your copy.
Should be right in here. System out print's good. System out print line. All right, fine. I'm gonna look at the error. Whoa. Error, illegal character.
Oh, it's a different quotation.
Ah, yes, it is. Hate that. Yes, it's a different quotation mark because I copied off the slides. All right. That happens quite often if you copy from somewhere. You get some other funky character. I was like, what the heck? It looked good. All right. All right, let's run it.
But that's crazy that it picks up such minute...
I know, and it's kind of nice it does, though. I especially like it when someone turns in reports to me where they copy off Wikipedia and I get the nice blue background or something. Or when someone turns in a Java program they copy off of justanswers.com and it has the 1, 2, 3, 4 down the side and they don't remove the numbers. So it doesn't compile. I'm like, oh, look, it's even got the numbers. Yeah, it's like...
Justanswer.com. Is that a good place to go?
It's a nightmare. Problem is they give you the answers, but they see a lot of the programs I assign, I change slightly, quite frequently, like every semester sometimes. So what happens is you go up and you look for the answers, and the overall program looks about right, but I changed something. Like on one of the programs I assigned one of my classes, it didn't use an array, and now it does. So I know people turn it in with no array. I'm like, oh, I know where you got that one from. So. It's not so great. All right. And plus, you're paying people to do it, and there's no guarantee they did it right. A lot of times they don't. And they always put the style wrong and all that stuff. So, all right. So this program ran. It started at 10, went down to 1, said liftoff. Okay. So now let's talk about this loop. The charts, the slides talk about it, but we're going to cover it first. Okay. So for loop starts with the word for, and it has some parentheses. Inside the parentheses, we got 3 items. Item 1, item 2, and item 3. Okay, that's pretty much how a loop works. Okay, we have what's called the initialization. So what's happening here is we're declaring a variable called I, setting it to 10. Everybody see that? Then we have the condition. So we're going to continue as long as I is greater than 0. That's the way we read this. And with each time, this is the update. We're going to subtract 1 from I each time. Does that look familiar? It looks like a compound operator. No, a incrementer, decrementer operator. Okay. So what happens is, we get down here, we set I to 1 or to 10. We check. Is 10 greater than 0?
Yep.
Yes, so we're good. All right, so we jump down here and we print out I, which is 10, and a space. Then we go to the update. 10 now becomes 9. Then we go back to the condition. Is 9 greater than 0? Yes. Go down and print 9 in a space. Go up here. 9 becomes 8. Is 8 greater than 0? And we continue on until we get to a 1. So we print 1. 1 minus becomes 0. Is 0 greater than 0? No. So at that point, we jump down to right here. Then we print out lift off. Okay? Let me show you how you're going to screw this up.
You could actually,
Go ahead.
just saying, if you wanted it to count to 10, you could just put I is greater than 10.
Right, we could actually change this to,
I plus plus.
we could change that to 1 while it's greater than 10. No. Greater than 9. No. Is it? Yeah. 9. Is that right?
Yep.
As long as I is...
No.
No, that's wrong.
That'll end.
As long as I is less than 10. Yeah, that'll still work. Less than 10. Let me run it. What am I doing wrong?
I is greater than 0.
Is I greater than 10? No. Is I less than 10? There we go. Phew. There we go. I was confused there. All right. It's hard sometimes those to figure it out. So what happened last time? We started at 1, we went up to 9. If we wanted to do 10, we would do less than equals. Or we would say less than 11. So, all right, not a problem there. Now, I'm going to show you how you're going to screw up. I could have actually declared I ahead of time. Integer I. Then I could have said I equals 1. Are we okay with that? I declared on one line, assign a value on the next. Not an issue, it's still going to work perfectly. Okay? What's going to happen is you're going to do this. You're going to put a semicolon there.
Yep.
And you're going to run this loop, and it's going to be perfect. And you're going to say, 11 liftoff.
Wait a minute.
So what the heck is 11 liftoff? What happened was, this semicolon was the end of the loop. So it set it to 1. Is 1 less than 10? Yes, great. It does what's right here. Oh, nothing. It increments. 1 becomes 2. Is 2 less than 10? Yes, it does right here. Oh, nothing. So it's going to count up, and it's going to get to 11, because it's going to increment to 11.
It's going to print.
Is I less than 11? No. At that point, okay, now we go to the next line. So that's why it prints out 11.
Until that statement is
Right. Watch that. So many times people put a semicolon at the end of their for loop.
That's that one and putting the brackets backwards are two things that
Yes.
I messed up a lot.
I had a guy in my other class, he used this as brackets. He couldn't find it. He's like, what the heck is going on? I said, dude, you got 2 starting brackets. Where's the ending
Or you
brackets?
put them backwards, like that one there would be, opposite on.
Right. So watch this. You do not want a semicolon at the end. All right. I'm going to lift off. I'm going to do this here. Plus I. Okay. I just want to see what the value of I is after my loop. Okay. So I'm going to run it. I has the value of 11. Y'all see that? Because I told you. It starts counting, it exits, and it goes. But what if I put it back the way it was? Now what's the value of I? Well, I can't even compile. What the heck did I do? it says error cannot find symbol, and it's pointing to my I. It's right there. And I is an integer. So why isn't this working? Anybody?
Because you're trying to add a string to an integer.
Nope.
It's out of scope.
It's out of scope. Very good. Let me tell you what scope means. All right. See how inside this loop, remember this for loop pertains to this next section only. Basically starts there and ends there. That's it. That's the whole loop.
Oh, it doesn't carry the...
Right. The integer, the I is declared inside the loop. So the scope of the I is right in here, and that's it.
Okay.
So that's why when I defined it ahead of time, it likes it.
Okay.
Because the I is defined outside the for loop, so that I is going to work from here all the way down to here. It's going to work to the end of the main method. It's defined at the main method, so we can use it inside the main method. But when it was defined the original way, oops, if you spell integer correct, it's only good inside the loop. Okay? So which one do you think is better?
Outside of the loop. I
Depends
guess
on
it
what you're
depends
doing.
on...
It really depends. I mean, if you want to use it afterwards, outside the loop.
Right.
But the whole point about programming is, or one of the points is you want to limit the scope as much as possible. Okay? You don't want a variable to have existence where it doesn't need to have existence. And by declaring it up here, like this, what's happening is we're giving it usage where we don't need it. And that's just one more thing that could screw us up.
Right.
Okay? So you're best to declare it just where you need it. I got contacted. Man, this is 96 maybe, something like that. A friend of mine ran an ISP, and he wanted a program that was written in Visual Basic that displayed images of checks. Kind of like we all do in our banks now. Online, you can see the image. Well, there was no online banking at the time to see that. Well, he wanted it done. So he contacted me, and he gives me this program to convert to a web page so a bank could use it to display checks. Awesome idea. I said that would be perfect. So I got this Visual Basic program, and I converted it to through using C++. ISAPI basically is what you had to do. You had to make an ISAPI DLL for Internet Explorer back then. And their program was, I've never seen a program written so bad in my life. What they had was a one file with all the global variables defined. 100%. Every variable was defined in one file. Then all the other parts of the program, just used them all. You didn't know where they came from, where they got changed. So, man, trying to figure out how that program worked, it was terrible. It's kind of like having a bunch of phone numbers, yet you don't know which phone number belongs to what person. So, and, you know, I actually got it working, and what made me so mad. Got this thing working where you could log in with an account number and see a check. Proof of concept. You know what they said? No one will ever want that. So the bank said, we don't need it. No, we don't see any use for that. People don't want to be able to view their checks over the web, so they didn't do it. I'm like, dude. Now look at it. Everybody wants it. Also created an auction website way back before eBay. Nah, no one's going to use that either. I'm like, now look at eBay. So, oh well. But that's another story. So, but the whole point is, yeah, you really want to define your variables so the scope is exactly where they need to be used and nowhere else. I could have defined it, at the top. But then it could have worked everywhere. I mean, in this program, no big deal. It's not big. But what if it was big? What if I could change it in 27 different places? We're going to learn more about scope here in, I think, the next chapter. But so the point is, try to make the scope as limited as possible. So this would be the best way to do it, unless I needed it outside. If I needed the I available after liftoff or something, like here, actually I could do this. Let me show you this. And I could actually, this would be a good example. All right, what is going to print right down here? Anybody? 10 or 0? Let's see. Got 2 votes. Huh. Error. I is already defined. See how I have I defined here and I defined here? It's not going to do anything. All right. Now I got rid of that. So what's it going to do now? What do you think? It's going to print 10. So I actually could have put the I plus, oops, oi, oi, yes, exactly. All right, could have put it like that. So we had the same output. Not quite as nice as the other one, but, you know. So we could do it. So it really depends on the scope of it. All right. All right, for loops. This is before the start of the first loop iteration, execute the initialization component. That's this I equals 10 part. The top of each iteration, evaluate the condition. So this I is greater than 0 condition part. Okay. If it's true, execute the body. If this is false, you're done. Terminate it and move on beyond it. Just like I showed you. At the bottom of each iteration, in other words, after we printed out this I, so at the bottom, jump up, it says at the bottom, execute the update component. That's this I minus minus. All right? So the order is 1, 2, 3, 4, 5, 6, 7, 8, 9, so on and so forth. This one gets executed one time. This one at the top each time, checking it. And this is the update. Okay? Easy enough? Wow. 20 minutes and we covered one slide. Nice. All right, let's see what this does. Trace this code fragment with the input value of 3. Okay? We're going to do this. We're going to trace it. I'm going to copy it in so we can trace it in another place, though, so it's easier. Let me copy. All right. We already got the scanner defined. Let's copy all this baby. Let's see if we copy it with the correct parentheses this time. Oop, wrong.
It won't.
Think so?
Nope.
All right. All right. See, doesn't it look so terrible like that? Whoops.
I actually did.
All right, now it looks so much better. All right, so let's talk about this thing. All right, we're not going to run it yet. We're going to actually walk through it. Okay, so obviously we got our scanner. So we're defining a number. So I'm going to get down here to my bottom of my slide. I'm going to say, okay, now we have a number. Whatever that meant. All right. Now we have a factorial. So I'm going to go over here and I'll put factorial. Okay, what's the value of number at the moment, right up here? What's the value of number?
And then 0. Or do
No,
you
you don't know.
We don't have a clue. Don't know.
Yes.
How about the value of factorial?
1.0.
All right, so that's what we got right here. At this line, we got 1.0. Okay, output is enter a whole number. I'm just not going to type that in there. Okay. This line, what happens? What's this line do?
It initializes the keyboard.
Replace the key
Reads
or
the
the
input.
cursor at the next
No,
line.
it goes
Okay.
next.
All right, this one outputs on the screen.
Oh no, integer.
This one has it waiting for input. It's blinking in hungry. It's a hungry cursor looking for what? An integer right there. All right, so it's blinking. It's going to get input, and it's going to store the number. Well, I entered the number 3. So I entered a 3. Okay, so right here, now number has the value 3. Factorial is still 1. Okay, get to our for loop. Now we got another variable. We got a variable called I. What's the value of I?
2.
It is a 2. Because we declared it, initialized it all in 1. So we say is if I, or basically is I less than or equal to 3? What do you think?
Yes.
Yes, it is. 2 is less than or equal to 3. So this is a true statement right here. So factorial, whoa, what's that mean? How can I write that another way? Factorial equals factorial times I. Make sense? Hopefully everybody got that. That's that compound operator. So factorial equals factorial times I. So factorial is 1. So factorial is now equal to 1 times I. So what's factorial become? 2. 2.0. Very good. All right, so this line, now we have number still at 3, factorial is a 2, and I is a 2. Okay, next thing is the update statement, this I++. So what happens to I?
3.0.
Becomes 3. 3.0 or 3?
3.
Just 3, because I is an integer. Okay, even though factorial was being multiplied by an integer, remember, factorial was a double, I was an integer, became larger. Okay, so I became a 3, we check it. Is 3 less than or equal to 3? Because we're comparing I with
Yes.
number. So is 3 less than or equal to 3? Yes. Okay, move into here. Factorial is equal to factorial times I. So factorial is equal to 2 times 3. What's factorial become?
6.0.
Number still has the value 3. We haven't changed that. Factorial has 6.0. Okay. Now we come up here. Increment. What happens to I?
7.
4.
Oh, okay. Value.
Yeah, 4.
7, where'd you get 7?
Because he was incrementing the 6. Alright, so factorial is 6. Then we increment I was 3, so now I becomes 4. Then we check it. Is 4 less than or equal to 3?
False.
That's a false statement. So we jump down here and we say what? We say 3, because number's still 3. So the output will be 3 explanation point equals 6.0. Correct? What do you think? Well, let's run this baby and see if we did it right. Hopefully it compiled. Let me see if it compiles.
Just said I'm so confused, I have no idea.
Because I don't understand. Enter a whole number. 3. Oh, yeah. Let's check it out. Let's check out our results. See if we're on the money. That's pretty darn close, I'd say. 3 factorial equals 6. Yeah. Very nice. But the cool thing is, now we can change it. Let's put in 6. Wow. Let's put in 1,000.
Equals infinity.
Too big a number. Because that's basically each number times the next number. So let's go with can I go as high as 50? Wow. 3 point whatever times e to the 64th.
It's in pi.
Oh. Yeah, well, that's right. It has to be an integer. If I put in 3 or 4, it ain't going to like it. Let's put in 15. Damn, that's still too big. 10? Okay, 10's livable. 11? 10's about the biggest one we can get before we start going to exponents, exponential notation there. Alright, everybody okay with how that worked? Kind of easy enough there? You walk through it? Alright. Great. Write a main method that prints the squares for each odd number between 1 and 99. Alright, we got to do this. Sorry, have to. Okay, remember, write a main method that prints the squares for each odd number between 1 and 99. Y'all need to help me here. I ain't going to do it all myself. Obviously, we need a loop.
1 to 99.
No, not 1 to 99. We don't need this stuff. We need to print something, so I'm going to move that. Oh, I think I already showed you guys this. But did you guys know you can take something and drag it?
Yes.
Okay. Not sure if you remember that. You can drag something. Alright. So I need to print something. The squares between 1 and 99. So what do we need to start with here?
1.
And up to 99?
Wouldn't you get rid of that lesser than sign?
I don't know. Let's see what it does. I'm going to run this thing. There you go. I got 1 to 99. Okay. Now, what are we supposed to print again? It prints the squares for the odd numbers between 1 and 99. So what's a square?
Square root. It's number multiplied by itself, so you go.
Okay. So if I did I times I times I Is that not the squares?
It
So 1
is,
times 1
but
is
it's
1.
doing it for each
2 times
number
2 is
between
4.
1 and
3 times
99.
3 is 9. Okay, so we got the squares. Now what do we need to do?
Between 1 and, so you have to put a limiter.
Print the squares for the odd numbers between 1 and 99.
Yeah, so instead of the incrementing by 1, you'd have to do increments of 2, so plus equals.
So I put another plus plus?
No, plus equals 2.
Would you use a modulus operator?
That's for determining if it was odd or even. This one will just do it. So it's okay, so we got the square of 1, the square of 3, the square of 5, the square of... So did we do it?
Well, with the exception, number has to be less than 99. Are they talking about the integer?
Well, here's the way. You can read it two ways. That prints the squares for each odd number between 1 and 99, which we did. They didn't say the output had to be between 1 and 9. They said the numbers that we were squaring had to be between
That's
1
kind
and 9.
of what I thought it was.
Yeah, you can write it two different ways. What if we wanted it to stop at 99? Let's do that. How can you make it stop at 99?
Very carefully.
Okay, so how do I program? Very carefully. There's a couple different ways. I can use an if statement. If I times I is greater than 99, break. Remember break?
Oh, yes, break.
Break your leg.
Let's try it.
Dun-dun.
Just did it.
I'm impressed.
Wasn't that pretty simple?
It was.
Yeah, so that one's weird. You can always write two different ways. So it's like, how are you going to read it today? I honestly think this way is better. Because these are the squares of the odd numbers between 1 and 99.
Technically, that is right.
You're right.
It's actually, the output's not displaying correctly.
It's not? Why?
The square root of 99 is not.
No, the square, not the square root, the
Or
square.
the square of 99 is not 9,801.
Hold on. You know what? I know somebody who knows that answer.
10,000.
99 times 99.
2 minutes in class.
9801.
Yep, calculator knew it.
Just quit.
My brain hurts.
We
All right.
did straight math beforehand.
Oh, yeah, I totally understand. Yes, I understand. All right, so everybody agree we did that? But see, what's misleading is his output. His output stops at 81, but he does have the dot, dot, dot,
That was on purpose.
just to confuse us. That's why I always write it both ways, so we can figure it out. All right. Man, we're never going to finish this. We're going to be here till Monday.
Not at this rate.
All right. So let's talk about the loops. See, I like giving you guys examples. It's
I want to do that homework.
good learning. All right, so a for loop, if you know prior to how many times you can do it. A do loop, if you always need to do something at least once, a do is a post test, and a while is a pre-test. Okay? Says if you can't use a for loop or a do loop, use a while loop. I think that's pretty lame. If you can't figure out how to do anything else, no. No. I would say that I can pretty much use a do loop or a for loop for everything. There's always ways you can use breaks or something in there. But all right, let's continue on. You could also have nested loops. We're not going to do this one. But you could have a loop inside of a loop. Something like this. We have a height of 4, width of 3, so it's going to print 4 rows and 3 columns. Okay? So you could have one loop that goes, prints each one, and then another loop that goes 4 times. So there's multiple ways to do this. But you can't have loops inside of loops. Okay? Now the last section of this chapter is about, I don't know if it's Boolean or Boolean.
Boolean.
I've always thought it was Boolean.
I think it's Boolean as well, but just in case, I don't want to offend anybody. It's one or the other. Okay. It says programs also need to keep track of the state of a condition, and Boolean is usually used for doing that. It says if you're writing a program that simulates the operation of the garage door, you want to know when it's open, you want to know when it's closed, so on and so forth. Yeah, and we got garage doors here.
Not
Love.
here, but I got one
Yeah, yeah, not here. True, I don't have one here either. But you know, the one thing that drives me crazy about my garage door, I have a cat that we kind of adopted a couple years ago. That was a stray. She was like, super thin. Now she's all healthy and everything. Never fails. I come home, open the garage door, drive my car in. She runs out of the house because I have a little cat door and stands right there in the middle of the door. Just looking. It's like, get out of I can't close the door. Because it's got those sensors, I'm going to move the sensor one day. That way you go, no more cat.
The sun affects
Oh,
those too.
Sounds like the answer to me.
The sun actually affects those. Like my neighbor across the street from me, he always has his garage door open, and I asked him one day, I was like, you need to close your garage door. And he says, I do.
The infrared.
And the sunlight is hitting on it, and it causes it to go back up.
Wow, that's weird. Huh. I don't know, my neighborhood, we have too many cops, I guess, because they'll come by about 3 in the morning and say you left your garage door open. So it was really pretty handy. So, all right, no, you could understand how the garage doors might be good for this. Okay. You want to keep track if they're up or down. Okay, a Boolean variable is a variable that is of type Boolean, just like we did int and float and long and string and char. You can do Boolean. Okay, you can hold true or false. That's it. For a garage door, it could keep, is it up, true, if it's down, false, that kind of stuff. Pretty simple, okay? Here could be the code fragment. Okay, it says the code fragment initializes the up direction variable to true and shows how to toggle it. So, if up is true, we do something, then up becomes the opposite of what it is. So, if it's true, it becomes false. If it's false, it becomes true. You see that? That's a good way of using the not. So remember, up is true in this example. So then up becomes the opposite of true. So what's the opposite of true? False. So up becomes false. The up direction becomes false. Then when we go through this loop again, remember up direction is false. So what's the opposite of false? True. So it's set back to true again. It's kind of like in my garage door, I hit one button. I don't have an up button and a down button. I just have one button. If it's open, I hit it and it closes it. If it's closed, I hit it and it opens it. Easy enough. Okay? All right. And there's the garage door program. Okay? One of these days I was thinking about making one that was all graphical, which I totally forgot to bring for you tonight. Maybe we'll do that next class. But you need to remind me. You asked about GUI last time.
Yeah, the J option thing.
I totally forgot about that.
That's okay.
Sorry. I had some issues today. All right. So, but this is an example. We're not going to walk through it. Okay, it's too much work. Because it kind of sucks because it's instantaneous. We need to make it with a weight in it. We're asleep, but not there today. All right, let's talk about input validation. Booleans also are often used for input validation. Okay, to check if it's valid or not, if it's correct. It says, if it's valid, it continues. If it's invalid, it stops, or it warns them you screwed up or something. Okay? And here we'll look at his example. Okay. All right, it says to add input validation, replace the garage door program prompt with the following code. Okay, so now we're saying press enter or Q to quit. Okay. So now it's going to continue unless we hit Q. Other than that, it's going to be true. Okay, it's easy enough to do. Okay. So if it's Q or blank, it's enter, it's valid. Otherwise, it's invalid. So it's just, you can do for all kinds of stuff, okay? Now, Boolean logic, some of you are in discrete math, so you already know all this, okay? It's a form of logic that begins, or that determines how they're evaluated, okay? This is going to be the last section we're going to cover in this chapter, okay? We know about and, we know about or, we know about not. Hopefully you all know those. If you don't, you need to know them for the quiz, okay? For the and operator, both sides must be true, okay? So it's like, is the school open, and a weekday? They both have to be true for me to come to work, okay? Or, so they both have to be true. With an or, either side can be true. This or that, one or two, that kind of stuff. And the not just reverses it. So there's an example here we're going to walk through. Okay. Now, assume that OK is false. Everybody okay with that? OK is false. X is 2.5 or 6.5 and Y is 10. So let's look at this guy. All right. So what do we do first on this thing? We do the parentheses. So 6.5 is not equal to 6.5. True or false? It's false because it is equal to it. So the left, I lost one. There it is. The left side is false. Then what's this right here?
False or.
This is an or. OK is false. So we got false or
True.
not false. And what's not false? True. So false or true gives us true. All right, let's look at the second one.
Wait, now what? Say that last.
False or
True.
true gives us true. Remember, or either side can be true. Either side. That's why a lot of times students will ask me something with an or statement. Are we having class today or is school closed? Yes. I mean, either one. It doesn't matter which one. I don't have to tell you which one because an or statement, either one can be true. So I always do that to my students, and they always send me new. Okay, they ask me one question. Then I tell them yes or no. So, all right, let's look at the second one. True. Now we have an and. With an and, what has to happen?
Both have to be true.
Both have to be true. So obviously we're on a good start here. We got a true on the left, so we're good so far.
So far, yeah.
Now we're saying 12.0 is less than x plus y. So what do we do first?
Add x plus y.
Add x plus y. So what do we get?
16.5.
16.5. So 12.0 is less than 16.5.
True.
True it is. It's like 4.5 less. So now we got true, and true gives us true.
Do we add x plus y first?
Yes, we should add x.
The division would take precedence over the addition.
Where's the division though? That's a relational.
Well,
Yeah, yeah. Yeah, you're right. If it was division, it would have been.
I was reading that.
Is it division?
I'm sorry.
That's all right. It's all right. So yeah, if it was division, you're right. That would have been done first. So all right. So it ends up being true there. Okay. Everybody okay with that? Everybody okay with chapter 4? All right.